In this video, I'm going to be discussing about Boolean logic for DevOps. Uh, Boolean logic is required for all developers as well as all students, no matter if you're studying computer science, a major, or you're studying electrical engineering, civil engineering, philosophy, mathematics, every aspect of life, you can face some sort of logical thinking. Behind Boolean logic or Boolean algebra, there was the father of George Boole, which I'm sorry, George Boole is known as the father of Boolean algebra. He was a 19th century British mathematicians that who invented Boolean algebra, and then his contribution was attributed to the design of digital computer circuits, the gates and all of those, and gate, OR gate, all these comparison Boolean operators that we're using with Boolean expression, which I'm going to be discussing as an example with Python. Maybe not Python today. I'm going to be discussing PowerShell. On another session, I could cover Python as well, because in one video it's going to be too much if I cover every set of programming languages. But the concept of the syntax of the language is one thing, the semantic, which is has to do with meaning, it has to do with the logic. So all this semantic that you're writing, the logic of these operators, comparison with Boolean expressions, basically it tells you whether it runs at the runtime dynamically, at runtime is going to perform well, or just have some kind of issues or bugs at operations. So it is essential for DevOps to make sure their code is tested a number of times on the development and the testing and the integration before they go to operations. That's why Boolean logic is a must knowledge that you have to know. If you don't know that one, you're going to have a hard time. And then by knowing the Boolean logic gates and all the circuitry, not that you're good at digital circuits and chips and other ones, design and implementation, but also writing algorithm and programs that are much efficient, because at runtime all those code are going to be executed. I'm going to also be talking about Augustus de Morgan's, because he is the father of negation law, which is kind of like one of he was also a British mathematician that lived in the 18th century, and both of them, unless unfortunately, had a short life, but unfortunately they passed away after his son died and his daughter died, and then he had some kind of psychological stress that took him away. But his contribution was basically, he was also a British mathematician, a logician, as well as attributed to De Morgan's law, his law, and then negation, and then also relating to a logical conjunction, disjunction, and negation. So the negation, you could do like a conjunction and disjunction on the union and intersection, and we will show you that one as well. And then also he was the mathematical induction was termed after him, basically coined the term mathematical induction, the induction law. And then in philosophy, you have seen the induction law that implies for the simple test is to make sure that you test it with P of 0, and then P of 1, P of 2, and then once you test it for P of 0, the pattern that it's true for the first one, it is true for n1 of them. Now, it doesn't matter how many is the n. So, and that's the law of induction. But George Boole, which is basically the Boolean algebra was invented by him, is one of the, yeah, I believe he only left 49 years, as you can see here, but he had a short life, but he was the university professor as well as at Lincoln University, and then also he contributed a lot of uh, kind of like invention in that terms of Boolean algebra and the father of algebra. So I'm going to be discussing these two, but I wrote here the knowledge of Boolean logic, or Boolean logic, not Boolean algebra. Logic, what I mean is by logical operators and logical expressions and all those comparison statement that you're doing it with if statement and while statement and for loop, all those ones, and any programming language you're doing some comparison, and those logical statement at runtime it will execute. So it is a developer or DevOps a must, and then also for every college students, because if you're great at mathematics and also for kind of philosophy and logical thinking, you will do great at school as well. So no matter what is your major, you could do these things pretty well. Let me move this one out of the way. The Zoom is blocking my face. I'm reading the information, so blocking my eyes actually. So on this one, we have a if statement in PowerShell. The syntax of a PowerShell if statement, if it says if and then between left parentheses and right parentheses, it says if condition. This condition could be a Boolean expression, could be any comparison. If 1 is equal 1 or 2 is greater than 5 or 2 is less than 5, or any of the comparison that you do could be some formula and anything. I will show you later on some of the examples. So you do, if this condition is true, then you start this brace and right brace, and between this block of code, this execution become of essential. So whatever is this condition, if it is true, it runs this block of code, execute when the condition is true. Otherwise, else is gonna just say execute the condition is false. So the statement that you're doing it in PowerShell, you could put to a left parenthesis to comment it. So this is not a statement; it's just a word that or a sentence that I commented as a comment. And so you can write any kind of PowerShell block of code between this brace and that brace to just execute it. So this is the if condition. Now, if you look at the if condition, I'm giving you a little bit more example here and say if condition execute when the condition is true, else the condition is false. So this is kind of like a detail of that one, but what is a condition? What is a condition? A condition could be a comparison statement. So you could compare apple and apple, you could compare apple and pear, or you could compare some numbers, you could compare some functions, you can compare some kind of objects, anything that is in life, you can compare them, strings, numbers, floating points, everything. So also you can have an expression in the condition. The expression could be 2 plus 5 is equal something, or some kind of formulas, or some other ones, x is equal y, x being one value and y being another value, all kind of things. Can be a Boolean expression. A Boolean expression could be, because of Boolean logic, you could have a number of statements that could have or one Boolean expression that could have a value of true or false. When the Boolean expression is evaluated, and then the value is going to return either true or false, and then if it is true, then the block of code executes, otherwise it moves on to the next instruction. So, and then also it can be more than one Boolean expression. So Boolean expression, it could be two or more. and so, or one or more Boolean expression. So if you could have 10 different Boolean expression, and each one of them has to be evaluated, and when the value of those 10 just return a true, the next statement instruction gets executed. That's how this condition matching is there. And also this a Boolean expression exceeds the command, and then here I'm just basically rewriting this information to just tell you a little bit different colors, but here is a good example of the flow chart, the flow diagram. So in computer science or any other major, when you write a code, you're supposed to start off with how your programs are going to start and how it ends. And in order to see the flow chart or flow diagram, in this case, on the PowerShell syntax, the if statement has a left parenthesis, right parenthesis, this is the condition. Inside this parenthesis, right parenthesis, you put the block of condition, and then the statement that follows it, it execute those statement inside. And this left bracket that I put with the right bracket between the else part, the else part between them, this is optional. So you may not have an else part, but if you do have an else part, you have to have after the else some statement to execute the when else is true. Everything else fails, and then else become true, and then in that condition you have to have a statement. So like you can see here, the condition is checked. If it's true, the statement for the if block is going to run, and then the program ends. If it is false, then the else code runs, and then the program it ends. So here's another example of if else statement. For the if else, if, and then else is the last one that is going to be compared. Again, these brackets with the white that are showing, those are optional, because you might just have an if statement and then the condition, and then the block of code to execute. So in this case, is condition 1 is become true, block of code 1 runs, and your program ends. But if condition 1 is false, then you have an else if condition. If condition true is true, then the instruction on block of code 2 runs, and then your program terminates or ends. If condition 1 failed, then condition 2 failed. Now you have condition 3 or condition 4 or condition 5. This the n is just representing as many as you have. This is why this is also optional. As many as you have, this one is saying that else if you could have a dot dot that has many of it, and then you just run them. So this is going to run for condition n, and then if otherwise, you're going to come to the else part, and then you're going to just get a default code for the else when everything else is not true. The else part is going to go to the default code, and then you just say nothing matched or something, and then you just terminate your program and exit out of the program. So that's a syntax of else syntax here. At the same time, I want to just point out to my Web University YouTube channel. And so I just did this video for Muhammad Musa al-Khawarizmi, who was the father of algorithm. Actually, he was the father of algebra. Algebra was invented by him in the 9th century. And then this video is very nice about it. And then I mentioned about Boolean algebra, George Boole, and then De Morgan's law. Maybe I did mention it, but maybe not. But he was the father of Boolean, not Boolean algebra, but algebra. And because of him, and now we have on the 19th century, the two British mathematicians that who invented Boolean algebra and De Morgan's law. And so, and those ones, George Boole and De Morgan's, Augustus De Morgan's. So make sure you watch this video, but this video is going to help you also understand some of these concepts here. And then at my Web University, actually, I have a lot of videos you're welcome to watch them. Today I'm going to demo PowerShell, and then in order to do PowerShell, I already went to learn.microsoft.com, because if you look at the About Logical, they already have a number of examples that you can do these comparison of these Boolean expressions. So if I just go open up PowerShell here, just to give you a kind of an interface so you can see what we are doing here. If I just say get dash help about logical. So this is all the information that you can see what Microsoft already checking these variable that it was defined previously, and then just saying that, okay, you can do and the statement with dash and. So like the difference between what I earlier mentioned it about the syntax of the language. So syntax is one thing that you learn whether you learn English or Farsi or German or any other language that you, Arabic or any other Chinese, when you're learning it, there's a syntax of what is correct and what is wrong. A sentence has to finish with a dot or a question mark or an exclamation mark. So however you write it, and then it has to have a lot of definitions and a lot of nouns and adjective and verbs, and the grammar has to be correct. That's the syntax of the language. But on top of it, if you just look at the grammar is correct, then now you have to know about the semantic of it. The semantic has to do with meaning. So when you're saying, for example, if A is greater than B and B, A is less than 20, or B is less than 20, these are the operators greater than that the language syntax requires it. But the logic of it, which has something with the meaning, that means at runtime, when A is compared with the value of B, either that value becomes true or false. So that comparison is going to return a true or false. And then the same thing with the Boolean expression, saying if this is true and this one is true, or that one is true, then execute the block of code. So all of that comparison that you're looking at it here, one is equal one, and then and one equal two, result false, because this is an and operator. An and operator, when you're comparing it, returns false, because a true and false is not going to return true. All the expression, Boolean expression, has to return true in order for the and symbol to work. For the or, you can see here, for example, result in a false, and this one is result in a true, because one equal one, that's true. So then this is called in computer science a short circuit. Once it says one equal one, and then it sees a or statement, it doesn't have to, the computer does not have to even execute the next instruction. It says one equal one, that's true. So since it's an or statement, one of the value has to be true in order to return a true. So an or statement, that's how it works. True or false is going to return true. True and true is also returning true. Only false and false is going to return false. Everything else is going to return true. So that is these kind of XOR and not and all these instructions that we are going to check. I'm not going to go for each example as we go, but I'll show you some of them with the coding as well. And right here, you can see this is the case. And so about Boolean logical, you can also try with the examples, this one. So clearing your screen and then say this one dash examples, and it will tell you with more examples here. You can just look at it and then try the examples, or you could also go to what I did here on the Microsoft and just search for each one of them. I'm gonna go quickly over some of these examples because I want to show you the lab activity. So this is a website that you all could go on the Google and search it, and then Microsoft has number of PowerShell tutorials for the subject. So you're welcome to learn just on a daily basis and follow the guidelines. And then watch my videos and other people on the YouTube. And then if you have a specific question that is not here, somebody might just explain it on the video faster for you. So here you can see that it is doing some comparison. These dash greater than, this means if A is greater than the value of $B. These are variables, A, $A and $B. And this is dash and is saying that if this expression and this expression, both of them are true, then you have true. Or dash or means that if this one is also true, this statement will still execute. That is what that is saying. So there's the OR operator, and that you can check it, the XOR operator you can check, and then there's the dash not. Dash not is the De Morgan's negation law. De Morgan's is known, very famous for negation. And if you look at this video here that I opened, De Morgan's law on the Wikipedia, basically it's a very nice video that is put here. You can see A and B and then negation, right? Negation of it is saying that when it is that, you say A, decimal kind of like conjunction and disjunction. But there are other examples here where this is conjunction actually. A and conjunction B is or intersection, you could call it intersection, and negate it, and then that would be not A union not B. The opposite of it is somewhere here also, might be showing you, like here you can see that's how they calculate it. And then these are the gates on the computer. This is an OR gate, this is a NOT gate, and negate it with this symbol here. And then this is a kind of combination of those two, and then this is an AND gate. So two knots are done. You have to look at the circuitry and De Morgan's law, and then you can see some of these ones are showing. Let me just see if on this one, yeah, right here, you can see the not A and not B. The AND becomes a OR, and then the not A or not B. And then if what is A or B, and when you negate it, it's not A and B, the OR becomes N. And then similarly for the union and intersection, that you can just see the union becomes intersection, but the negation is just intersected there. And then that's some of these symbols, like right here. So a lot of ways that these symbols are written. So when I was a student at the time, we were studying discrete math and then digital circuit back in 92, 93 or 94. Those are good old days. We all memorize these things and practice with them and look at the definition of them and everything. So you can see here, for example, on De Morgan's law, what I was telling you about A union B negated, and then it becomes not A intersection B. Similarly, A intersection B union, it becomes A and not A union not B. And then those kind of things, you can see it. So that De Morgan's law is very important also for it. And then that's how, and then dash not is negating. So 1 equal 1 is going to return true, but when you not it, it's what become false. And then I'll show you some of those ones in PowerShell. So, and then also the AND operator, there's some comparison that you could do the AND operator to say if one element, a number is in the member of a set, or comparison in an array, or some kind of a string comparison. You can say if this string is in this statement or something. You could do the like operators, and there's a lot of them. So we could just right here, there's some of the comparison that dash not. But what's important is that I'm going to show you on the lab activity here. So let me just do control plus, make sure that this is much bigger. I'm gonna go to CD to the C colon slash. So now I have this one. And if I just say host name here, I could see I'm on a PowerShell. If I say $host, you can see that the PowerShell version that I'm using 7.4.3. And then this value of get dash host for the PowerShell as well as the $host are the same. So when we are comparing objects, we can compare objects together also. Let me just do one more thing here. So at this time, I'm going to show you some comparison. So if I say one dash equal one, you can see that it becomes true. And then if I say one equal two, it's not true. And then if I just say, okay, that let's do this one dash not and negate that one, and even though it was false, now if I just say negate that one, it becomes true. So negation of De Morgan's, every time you negate a false statement, you could negate it as many times as you want, and then true statement become not. Negation of a true becomes dash not, and now if I do it, then the negation of false becomes true. So why is that one? Because one equal to two is not true, so this one becomes true when you negate it. This becomes false, this becomes true. So as many times as you do. Similarly, if I just say one equal one dash n, one and two equal two, and then dash n three equal three dash equal three, you can see that we are all saying that a true and true and true is going to return a true statement, right? So now if I just make one of them as four equal three, it's not. So true and false is not going to return a true statement. So since it's an and statement, the and has to, all the value of the expression has to be true. So if I change this one to an or statement, it doesn't matter, it's going to return true, because true and true or false is going to still return true, because this is an or statement. But now if I just say this one is an or, and then this one is an and statement, this is an and statement, what do you think is going to return? One or equal one, one equal one, or that. So that one equal one is equal true, so it's going to return false, because this one is saying that the and statement has to be also true. So this and this one equal, those are true, but true and false is not going to return true. So if I just do this one and then remove this one is still false, because one or equal one is true, but the next one is false, so it's not going to return this one. So now I'm going to change this one to equal one, which is this one also going to say false, but I'm going to make the second statement. Let me just clear the screen. I'm going to move it up because sometimes it's harder to read that one. So this one is going to say it is false, because the first statement is not equal, so the and symbol, and we are going to have to this one, even though if this one is 3 equal 3, it's still going to say false. But if I just change this one to say 1 equal 1, and then this one, even though I say 4, is equal 1, and then this one is going to return false. But if I just change this one to an OR statement, it's going to return true. Why? Because it's short circuit. This one is becoming true. It doesn't even compare this one because it's an OR statement. Either one of them is true, the statement followed it is going to be running. So then you could say, for example, F a statement here. You could say F, and then this comparison is done. Remember the condition that we're doing, condition followed by the statement that you want to write. And so you could say write host, yes. And then that would just say yes. Why I didn't do it? Because somehow the block of on the condition, I did not put Boolean expression. So since it's to a statement, I have to say either this or that as this, and now it's going to be okay. And then that's gonna do it. And if I just want to say, for example, on the right host dash foreground color green, so we can see a green light if it is good. Let's see why foreground color right host somehow dash foreground color and then green, and now it should work fine. And you can see the green, yes. And then so why did it write green? Oh, because I put two greens there. Okay, so clear dash host, it's gonna do this one. If we run this one, it's gonna say yes. And then if that comparison, now if I just create a variable, say 1 is equal 1, normally clear screen, 1 is equal $1. So this is a variable, right? So I gotta say 1 is equal 1. Usually you don't define every number, right? That's a very a bad thing to do in programming. But I'm just going to show you that if you define like $2 is equal to, and then rather than using these numbers, we could just use variable name, $1 equal and $1 or $2 equal 3, for example. Let's say we didn't define 3 and then we are just going to do it. Let's see if this one is going to still return yes, because 1 is equal 1, so it is not short circuit. And then same thing with other statement, you could do it. I'm not gonna give every examples, but I want to show you a few things that is important with logical operators. So one thing that I did earlier, I told you the $host is equivalent to get dash host. So both of them, you can see that they're kind of like a hash table, a key pair value. So the key is name, the value is console host. The key is version, the value is 7.4.3. So if I just want to get that information here, I could just say get host.version, and I could see this one. If it is an object, you have to use it as an object. This one will give you the version. So if you wanted like the .build version information, you see the build is there. The major number is going to, the major should be 7, so then it's going to return 7. Minor, you can see whatever field that is there, you just have to put it, and then it's going to return that one. Similarly, for the $host dot version, you don't have to put this one within the left parenthesis, right parenthesis, because this one is already an object of this one. So if you say $host dot get type, you can see that it's an internal host, and the system dot host the type is that is going to return is whether it's true or false on the statement. So let me clear the screen, it's hard to see there. Okay, so if I look at this one and then I say dot base type. So the base type is not showing here. Let's say I'm gonna say host and then here say select star. That would give me all of them. And if one of the field is base type or not, that would give you that information. When you do a select on them, you could get this. But right here, I could say, give me name and then comma version and comma, let's say, run space. Run space too long. Let me just say current culture. So you can see those number of fields here. But at this time, I'm going to show you the difference between the $ host object and then the get dash host object. So let's look at it. So get dash host by itself give you everything. And then $host is also giving you exactly same thing. So now I'm going to show it to you that if we have to do a logical comparison between the two, for the get host, I'm going to type in just to get the version of it. I'm going to say, show me the version. And $host dot version is going to also show it. But now I want to just compare the two of them together. So if I want to just compare the $get dash host, this object has some attribute. Now I could just say tab it here, and then you can see that there's a lot of the attribute. One of the attribute is called equals. So equals, and then I could say get host and then $host. See if that is becoming true. So this statement is there, and then this one is equal, and now you can see this value is true because the two objects are equal to each other. And now if I just say, what about this one dot version with $host dot version? So $host dot version. Okay. Get host. Oh, I missed that dot here. That's why. So when you do that one, also becomes true. And let me run it there again. So get dash host dot version equal, and this one $host dot version becomes true. And I'm going to check the same thing with dot version dot build. Okay, so if I just compare the build of this one with only the version, it's gonna return false, correct? It is false. But if I just say compare it with build, now it's going to return true. Because those values, if I just run this one here, the build, and then say only run the build here is 3, and then if I run this one, the build, that one is also 3. It's like I'm saying 3 equal 3. Obviously, they are true, right? So that's how you could compare the Boolean expression there. Similarly, let's say I'm going to do one more test here. Say compare the build, and instead of build, I'm going to say major number, which is version 7, but compared with build, that's going to return false. And it's build is 3, and then the other one is there. So I have to compare it with major number of the $host version. Now it's going to say true, because this one is going to return 7, and that one is going to return 7, and then the other one also returns $7 major dot 7. So you're saying that if $7 equal $7, Obviously, that's gonna say true there. Let me just do this one. Since I did the equality, I did not write any statement, so it did not say write dash console and say yes, and then close it. So why did it not work? If 7 equals 7, then write host, and that's why console not in the statement that I wanted to type in. Sometimes because of so many programming languages that we all learn at the school, at work, and everything, and sometimes you say, well, on language, one you say console.log or something, another one is printf a statement, another one is print, another one write, another one echo. A lot of these languages, brace, colon, and all these things, every now and then kicks in, but you get the idea. So the write host, this one is when you run it like this, with the write host is going to do that. So that was the comparison of those two objects that is there. Now I'm going to just write some kind of comparison for variables names or something. And then if I say, for example, let's do that one at the end. I'm going to just show you one more example here of the if statement and everything. So like right here, you can see if I clear my host here, and then I say if 1 equal 1, we already wrote this one, and then the comparison is going to return. So in this one, in the version 5, is that dollar sign host is version 5. You can see 5.1. It doesn't matter which version, these commands are going to work the same way. So 1 equal 1, and then says you got the green light. So if I just execute this code, let me just put a clear host in front of us, clear dash host. So whenever you run it, you get a new clear screen, and then say, okay, yeah, save it, and then yes, the comparison is true. So 1 equal 1. And then if I put this one to change it to 2, 1 not equal to 2, then I should get that no comparison is false, right? But I have to save it and then run it, and says no, the comparison is false. And then if you want to just write output here with write host, you can put the foreground color and red, like you just could say write host and then dash foreground color and then say red, and then now it's going to just return this. So PowerShell is not case sensitive, so either way it's going to work. Here's another example that I'm doing some comparison here. So I define this array between 1 to 5, and then I say the mystery number in this case is 3, and then clear the host, and then I just say I use a for each statement, then I say for num and dollar sign array, whatever is the array is going to loop through it. This and the symbol is for each statement. It's not the n dash n operator. Okay, that's the difference. So here, if we say if mystery is dash n, which is a comparison here, and then finds it, then write it. Otherwise, it's not. So let's do this one, and then we run this one. Now you can see that the number 3 was in the array because 1 through 5 includes the 3. So it says no match found for 3 and 1, and because in each number we are going through traverse through the loop, and then as we go through the loop, we're going to check, and if it the number is matched, it shows that in green 3 is and with 3 match with the 3, the number that it matches. So in this example, which is very nice, you can just make this range as many on the loop, because sometimes you could do it with against an array that's much larger than 10 numbers. So you could do this one and say, go ahead, do it, and it only matches with 3. So if this one is 1,000, it doesn't matter, or 100, it doesn't matter. It's gonna just go through all of them and only find out the 3, and then the 3 is the one that it matched there. So I'm gonna move up here. You can see when it's 3, it's green, and everything else is false. Okay, it says no match for those ones. This is how you write code. You just don't want to have these numbers with certain words. So whenever you make a change, you only change it on the top layer, the value of it, and then after that one, everywhere you use the variable to point to that one, so you don't hard code numbers there. Even the array size, sometimes you have no options. You declare the array based on the numbers, and sometimes you create based on key, which is hash tables. So you have a choice of that one. Here's another example that I'm doing, but between array of 1 to 10. But in this case, the mystery number is 2-digit. One is the number 3, and the other one is 10. So we're going to a if comparison. If that comparison is failing, then we go and else if comparison. So there's 2 numbers. I'm going to check the first number against the number, then check the second number. And if there's 10 numbers, you have to do 10 times the else if there. And normally you use a switch statement. If there's too many of them, you just look at those conditions and different way of writing, branching and looping and all that things. So this example is also nice. I'm going to just run this one. Notice that when I run this one, because the number 3 is found when 3 match with 3, and the number 10 match with 10. So if I just put this number 11, which is not in the loop at all, then it should go to the last port saying that 11 did not match, correct? So let me save it and then run it against that, and then you can see the 11 was not matching with any of these numbers, but only 3 was matching. So the numbers that it matches, it shows it, and then 11 was not matching with any of the 4 through 10. But if I just change this one off, send to my array to 11, and then run this one, I should get 2 green numbers, right? And then that's what 3 is matching 3, and 11 is matching 11. And then if I just do this one to 20, obviously I still get only 3 and 11 matched. And you can see 11 is matched and 3 is matched, but the other numbers are not matched. So when I say Boolean logical is a must for DevOps, this is at runtime. You will only get it when your array changes from 1 to 1 billion or 1 million, then it is really, really hard if you don't test it in all scenarios. And then your code make sure that when it goes to operation, it is matching all the processes of the systems and the data, big data that is being manipulated at the time. And when it is operation, it's like almost you're in a World Cup for soccer, and then Messi misses a penalty kick, or Messi that who kicks and scored from outside of 18 yard all the free kicks, and then he plays there, even though this time on the World Cup he scored beautiful goals, and he scored including the penalties. But sometimes, no matter how much of practice and how much testing you do, there are such a situation that out of the servers that you run these programs, one of the package or one of the data or some users connectivity is different. And those are the times that when you see these values that you're expecting a 1, it comes out a 0 or something else. And that is, or you're expecting a 0, it's not returning a 0. So when it's not successful, those values, then it's really, really kind of like, oh, I missed the penalty kick when I scored 1,000 times from far away, or penalty kicks. And then I just don't know why it happens, because it's emotional involved, but the big data on the computer with DevOps, a lot of things are involved. So users, and then process operations and instruction, the data changes, all that thing. the packages that are installed on the operating system or the database or network connectivity. There's a lot of things. IO timeout and disk issues, processes failing or something. So let's go back to and this one. We already showed you this examples here. I was going to show you one more thing. Let me just remember what I was doing. I think I did that one as well. Okay, last but not least, I'm going to go about Boolean logic. We discussed about George Boole's life, the great mathematicians of the 19th century who invented Boolean algebra, and he passed away, had a short life, but he was a professor of mathematics also at Queen's College. And then also we discussed about De Morgan's law, which is negation. And then I showed you some example of the negation, how you negate it. And then he was also giving recognized by the induction law, and as well as mathematical inductions, which is this. This is a very good picture of induction law. You can see that mathematical induction can be informally illustrated in reference to the sequential effect, falling dominoes. Falling dominoes in this case is that if it is true for the first one, P of sub 0, then everything is going to hold. That's P of sub n. You can see here that information is explained here. So I'm glad that I found out the page that I opened. And this one is the induction law. But in addition to the induction law, he also was just recognized for his best De Morgan's law, which is the negation, the conjunction, disjunction, and negation in mathematical induction altogether and there. And what else? And there are some nice pictures on the Wikipedia and Google pages that I just saw them. And then I searched for like free downloads for these images. I found these ones and I just made the thumbnail for it. And thank you for providing these tools to others. So these famous kind of like inventors or the best novel people that invented like algebra for Al-Khwarizmi or algorithm that we know nowadays. Al-Khwarizm was the name is derived, algorithm was derived from Al-Khwarizmi, and Boolean algebra from George Boole, and then negation from De Morgan's law. I mean, De Morgan's from Augustus De Morgan's. So you can see a lot of those famous things from De Morgan's law from Augustus De Morgan. So what we are going to just show you next is that at my web university, please make sure that if you haven't subscribed, subscribe and make some nice comments so I feel the same kind of favor is returned, and you could also help out others that are in need of yours. So if you learn something, pass it on. Knowledge is power. By sharing, you make us all powerful. And then sharing is caring. Share the website with people. Share the videos, documentation. There's thousands of documentation on my website that I have. You're welcome to just learn Linux online on my website, mywebuniversity.com. On the first page, it's basically I have a lot of videos that is including the YouTube channel that you could go there and learn. And then if you say that, well, I like to practice them, you can go to mywebuniversity.com, go to the next page on table of contents. you see this book, The Direct Path to Linux Ubuntu. It has about 14 chapters. In each chapters, I explain a lot about Linux, Unix, Windows operating system, PowerShell programming, Python programming, Bash scripting, awk programming, C, C++, Python, everything. So you're welcome to learn them. And then at the same time, if you're on Red Hat or Linux Ubuntu and other ones, there's 32,000 PDF files that I wrote in Python that I generated for you. They're normally on text if you're on Linux machine, but on a browser, you don't need anything because I wrote everything in Python and I generated those texts to PDF files, and they're available for you. So let's say you're going on Linux, Red Hat, you can see that is 12,000 PDF file. Each one of them you click on, you get a PDF file for it in there. So it doesn't matter which one. And similarly for Rocky Linux, I have about 11,000 PDF files. You're welcome to just learn them, whether you learn C Shell or Bash or anything, Python, Java, and then the documentation is there. Similarly, for the dynamic generation, I have these ones that you could go in there and search for dynamic pages. You can learn the command, like for example, if you're looking for Bash, you get Bash stuff. And if you say, well, what about PowerShell? Can I get something? Yeah, if there is some documentation, small documentation on the Linux, that is available for you there. But if you're looking like, for example, Node.js stuff, and then there's more documentation, including like, in addition to coming out here, then because I wrote it in Python, I made it kind of like code reusability. So nodejs.org, you go there and then you could just get additional documentation. Or go all the way to nodejs.api. So the nodejs.api, you can also do Control F and then search for API, and then search one of two. So the next one is right here, and you click on it, and this is documentation for it, and inside nodejs.org/API. And then if you're looking for DNS, you can see all the function calls, everything, learn it from there as well. In addition, I also wrote on the main chapters of this book, like for example, chapter 2, 3, 4, in addition to teaching you Linux, but with videos and online courses, I also wrote for like chapter 2 through 4, a lot of commands, so you can practice them by reading like a book there. And then at the same time, you can run the command and get the output on the like processes stream 3 and so on, and then you can see the output showing there. So you don't need a Linux machine to test it. You can use my cloud, my web university Linux server. All you do is just have the desire to learn. You're welcome to come and practice. If you say, well, Wahid, I want to just watch the videos. Yeah, I made videos for you here. Chapter 1, part 4, chapter 1, row 1, and then part 8 for the last one. And all of these 8 videos are there for you. In addition, if you want to learn MySQL and other ones, you could do it. And some of those Google advertisement are there as well. And if you just say, for example, let's say get into the chapter 3, and then you say, what about the change mode? Can I run these commands on your server? Some of the commands, because of security, I'm not gonna allow everybody to change file permissions and create users and accounts. So I write a very nice way of documentation for you to practice it online and read it, and not to run the command on my server. Those are security reasons. And then everything else that are kind of like, you can run like df-h to get the output of it. Yeah, you could just run df-h and you get the output here. If you just say df-h with extended for file system, just the output there. And then if you just go to chapter 2, for example, the basic of Linux, there's about 33 commands. Let's say you want to do calendar command, calendar today, this month calendar, you can see it's July and it's going to show you. And then if you say, give me the calendar of 1970, you can run that one. If you say, well, I like to get a command like, for example, run the date command, then that is not going to be allowed. But if I want you to practice something, you can go on my web university on chapter 5. Let me just take you to chapter 5 first, right here, chapter 5, and then you could just run these ones inside here. You can run the commands. Like if you say run the date command, I will allow you. Run the ls-l command to get it, you run it. pwd, all of that. But if you say df-h, those are allowed less. If you say, well, rm-rf and star.cgi, then it's going to say this is not allowed. Or say rm-rf and then a root partition, everything there, it's not going to allow you that one. So I have to be smart enough to detect what you're running and what is allowed and what is not. So there are certain ways I could don't let you run commands that is allowed, SQL injection, all those things. I'm taking care of it through my Python programs that I'm checking for them. So this is one other one. I want to also show you one more thing on the main page. If you go to chapter 2 through 4, and any of them that you go, let's say on go on chapter 4, at the bottom of chapter 4, you can see that there's say Linux and Windows technical documentation. So I have about 32,000 PDF files for Linux Red Hat, Linux Ubuntu, and Linux Rocky, and so on. And then at the same time for Windows and PowerShell. So if you're looking at PowerShell, there's about 1757 it was or something. Yeah, 1757 commandlet. All of them in PDF files. So no matter which one you do, you're getting the output here in PDF format as there. So like, for example, we were showing you the command, for example, let's say write -host. You could see that the write host is there, and then that information, or any other ones like get -process. Since I'm just talking about get -process, let me just give you one more example of the like and other ones. So with the get -process, I'm going to do this one. If I say cd to this, I'm now on the command prompt. So if I say get -process, by itself, it's a lot of the commands, right? So then you can see that since there's 3 processes with Zoom, I could say get -process -name Zoom start, and then it's gonna just return that one. So this is one syntax here. Another one is that you can do a where clause. So if I could say this one and then pipe it and say where object is the $, brace, and then $underscore. That $underscore is like a $PowerShell item. So that one is the current value, that is the variable that is pointing .name. Then I could say -like is let's say Zoom, and then it will list it there. So this is -like, you can see that as Zoom. And then if I start a process, say start process, and then start calculator, right? The start process calculator, I just started. Now if I just change this one, the like is say start calc. I know that the name is start with some word with calc, and because I use the -like, and then I just put the asterisk, meaning that anything comes in. But if I know it exactly, and then I could say dash equal, then I could say here and say zoom, because those processes that are zoom. Similarly, if I want to just do this one with calculator, then I have to change this one to say match with calculator app. And then that one will just find that one. And notice that when I found it, then I can also do a stop dash process. So the calculator process will just die. And now I closed it. Now if I do this one, the calculator is not there. And then if I say alias for stop dash is alias kill is the same thing as a stop dash process. And then alias um, get alias itself, as you can see that get is pointing to the get alias, or get dash process would be like if I say get dash process GPS is the get dash process. So you can shorten this command here with this say get dash process, where process name is calculator. Since it's not there, it's not gonna find it. But if I say start dash process right here, calculator, and now I started it. If I just make it alias of this one, is going to find it. Now I could do a short for kill, and then I could just kill that process, because kill is there and then calculator is gone now. So now I just do this one, it's no longer there. Okay, I hope you liked it. This video, this was some examples with equal and like, also that you can do it within the piping and then other ones. So one last thing, maybe I could just do for showing you, for example, a string matching. So let's go say the URL is equal. I'm gonna put my website HTTPS actually youtube.com, and then say .com/ at my web university. So this is the URL, and then I have to put $ when I create the variable. It's not like Python that you don't have to do that one. So $URL now is pointing to my web university. So you can say $URL dot length, you can see is 36 characters. And then $URL, and then there's a lot of compare to, contains. So if you say, for example, contains, you can have, say, ends with ty and enumeration equals. All of these ones, you could even say $URL dot $URL. If that is equal, then it's going to return true. So a lot of these functions and methods that are available, and remote procedure calls, it used to be called function in functional programming. And object-oriented programming is called a method. So the equal, that dot operator is using the method equal. So $URL, you can see whether the get dash member, you can see all these methods that are available. One of the method is to lower. So if I say $URL to lower, and then just use the method, is going to change it to lowercase. Similarly, if I want to change it to uppercase, to upper, it's going to change it to upper. So it doesn't matter what you do, and then you just say, for example, this one, we could say the if statement that we were looking at, this one, it says true, then you could say if, and then you put $URL dot equals. You could even say if that is a variable is there. So if you could just say like this, then write post yes. And then now, since it wrote that one, and instead of saying yes, right, yes, then I want to do a start dash process, and $sign URL. So in this case, if the $sign URL is defined, then I want to open my web university.
Great people are self-managing. They don't need to be managed. If they know what, if once they know what to do, they'll go figure out how to do it. They don't need to be managed at all. What they need is a common vision, and that's what leadership is. What leadership is having a vision, being able to articulate that so the people around you can understand it, and getting a consensus on a common vision. We wanted people that were insanely great at what they did, but we're not necessarily those seasoned professionals, but who had at the tips of their fingers and in their passion, the latest understanding of where technology was and what we could do with that technology.
So on this one, Steve Jobs excellently mentioned that the greatest people or the real leaders are the one that technology is at their fingertips. And then the great leader, I think, is that when they make your life that have access to that technology at your fingertips. And then by just making you available to do whatever you want in your life and succeed there, that's an inspiration leader. I think a lot of people are out there. And when I was talking on the other video about Al-Khwarizmi back in the 19th century, he was looking at every shape of everything as the shapes of geometry, angles, and kind of numbers, and then finding out the distance between the two trees, and then all kind of angles with and the things that they did with what he did on the Boolean or the algebra at that time. And now we're in maybe he did it at the 9th century, and then now we're in the 21st century. Imagine 14 or 14 century later, now we're kind of like great, at everything else. All these Googles, Amazon Web Services, and Oracles, and Cisco, and all these companies in computer science, computer-related topics, AI, everything would have none existed without Al-Khwarizmi working on algebra and mathematics and all other ones that Newton and Einstein and everybody else invented. So George Best with Boolean algebra. Without George Best, there wouldn't be computer circuits and gates. And without Al-Khwarizmi, there wouldn't be even numbers to add up to come with those calculations. And within the De Morgan's law, there would be no negations and no induction laws. So those are the greatest people, people that they did the technology upgrades, and then we are all benefiting it. And God bless them all. I hope you subscribe and enjoy the videos that I have for you and learn from it, and pass it on to the next person. Take care. God bless you all. Bye-bye.